Hey everyone, in this video we're going to finish talking about functions. So we've talked quite a bit about them so far, and then in this last video we're going to be doing this objective here, which is to form the sum, difference, product, and quotient of two functions and look at some examples. Alright, so let's do some definitions first and then we'll get into some examples. So the sum of two functions, we're going to name the functions f and g, is just denoted like this, and it just means that you're taking one function f of x and you're adding the other function g of x. So the main thing with this is noticing the notation. You're going to see something like the left side, but you want to end up rewriting it like the right side in order to work on these problems. Very similarly with the difference of two functions, it's going to look like f minus g of x, and all you have to do, what that's saying, is saying f of x minus g of x. Okay, so like I just said, most of the time you're gonna end up looking at something on the left side the way this is written, but then what you do is you just work it out the way the right side's written. Okay, and then also we have product and quotient. So you have f times g of x. Sometimes you'll see this one like this. They won't even have that little time symbol. It'll just be touching almost like that. So that means we're going to multiply if you don't see a symbol in between, and that's just f of x times g of x. And then over here, this last one, this is f divided by g of x, and you just break it down as f of x divided by g of x. And then this is just to let us know that we don't want to divide by 0. Okay, so getting right into our examples. So our two functions, f of x is 2 over x plus 3, g of x is x over x minus 4. Okay, so those are given, and we're going to find the following. We're going to add the two functions in part A, we're going to subtract them in part B, we're going to multiply them in C, and divide them in part G. Okay, so adding the two functions, f plus g of x. So notice how it was given to us, and the very first step that I would recommend is doing right here, f of x plus g of x. If you just do this simple step, just write this part out, then it makes it just that much more clear on what you're going to do. You're going to take your function that was given for f of x, and then your function that was given for g of x, and just put a plus sign in between them. And so if you write it out like this, then that's very clear how you're going to set that up. And then that's the answer, but if you can simplify, you'll want to. So that is already f plus g of x, but we do want to go ahead and simplify this. So notice what we're doing here, we're combining fractions. So we want a common denominator, LCD. So the common denominator is x plus 3 times x minus 4. So notice this first fraction needed to be multiplied top and bottom by x minus 4, and the second fraction needed to be multiplied by x plus 3 top and bottom. And then now that the two denominators are the same, we can combine the fractions. So you just add the numerators. Remember how that goes with fractions? If you had, let's say, a over c plus b over c, once you have a common denominator, then you just add the numerators. So you would have a plus b on top over that common denominator of c. So that's what happened here with this numerator. If you just distribute, that's 2x minus 8, that's this part here. And then this is x squared plus 3x, that's this part here. And then we can combine some like terms. Combine the 2x and the 3x, that's where 5x came from. And then this is simplified. If we can factor the top, maybe something on top and bottom might divide out, but this one is actually as good as it's going to get, and this is the answer. So this is f plus g of x. Two functions got added together, and then we just simplify the way it looks. And so what you want to do is sort of notice the domain on these functions and see if you need to add anything about that. But on this one, it says the domain of f plus g consists of all real numbers x that are in the domains of both f and g. So this statement here is just to let us know that originally, if you recall, for the function f of x, the domain, if you look back here, I'll just kind of point to it. Anything could plug in for x except -3, because if you plug in -3, it's going to be 0 on bottom, and you don't want that. So we're going to exclude -3. And on the function g, let's go back to that one here. If you notice, you can plug anything in for x except 4, because that would put 0 on bottom as well. So the domain of G is all x's except 4. And so what this statement is saying is that this new resulting function, because this is a function, when we added f plus g, we got a new function as the answer. This new function, the domain of it, is just the same as the combination of the two domains from f and g. Notice we can't plug in -3 here, and we can't plug in 4 here, because they would be 0 on bottom, and so that would be the domain of the new function. The new function, I'll go ahead and put that together for you. The domain of it would be all x's, the set of all x's, such that x can't be -3 or 4. Sorry, that looks a little sloppy, but -3 or 4 can't get plugged into the new function. Okay, so that's this example. And real quick before we move on to the next one, what I want you to think about is when you first learned how to add numbers and do operations on numbers, like add, subtract, multiply, divide, the answer was a number. So now that we're adding and subtracting and multiplying and dividing functions, that's why the answer is a function, a new function. All right, so this is the domain in set builder notation. All right, now we're going to subtract. And so think about what the first step should be. It's going to be to write it as f of x minus g of x. Once you do that, then you just plug in the functions. And so what I would recommend is I would use parentheses or brackets when I plug in, especially with a minus sign, because a lot of times, depending on your function, you might have to subtract like multiple terms. So I would go ahead and do this, like either brackets or parentheses. But we just filled in f and we filled in g with a minus sign in between. And then we're going to simplify. Very similar to the last one, we have the same common denominator on bottom, and then we're going to go ahead and add the subtract the numerators. So this time we still had 2x minus 8, but over here this is x squared and 3x, but we're subtracting them. Okay, so that's why it's minus x squared minus 3x. And then combine any like terms, and then that one, actually you can go ahead if you want, you don't have to, but you can factor out that negative into the front, so it's like an invisible -1 right here in the front, and then that's why we have x squared plus x plus 8 on bottom. And then similarly with the domain, we have the same thing actually as the last one, because the denominator is the same for this new function, because this is the answer and it's a new function. We subtracted f and g, or g from f, and we got a new function as the answer. In the domain of that, we can plug in anything except -3 or 4. All right, next one, f times g. So remember what the first step should look like. Just write it separate. F of x times g of x. And again, I would recommend putting parentheses or brackets, especially if your functions have multiple terms. These ones, it doesn't really look too bad without the parentheses, but if your function had like x squared plus x plus 1, it would make a difference if you had parentheses. So I would just put those every time. Okay, so on this one, when you're multiplying fractions, because that's what we have going on here, you don't need a common denominator, you just multiply straight across. So on bottom, just x plus 3 times x minus 4. On top, just 2 times x. Okay, and then there's nothing that can simplify there. And then the domain still happens to be the same on this one, because the denominator has actually been the same on all three things we just did, parts A, B, and C. So this new function is f times g of x, and we can't plug in -3 or 4 still for this one either. So let's go ahead and do this last one here, f divided by g of x. So remember your first step, go ahead and write this out as f of x divided by g of x, and then fill in your two functions. And let me make it a little bit more clear. This is the division that you're performing. I just want to make it more clear because our functions have the fraction bar in them already. Okay, so this is the division that we're performing. And then think about what we have here. When we're dividing fractions like this, we're actually going to flip and multiply. So I'll show you off to the side. A over b divided by c over d. You're actually going to flip the bottom and multiply. So multiply by the reciprocal of the denominator. So it's going to be a over b times d over c. Okay, so that's how we do that one. And so I'm going to go ahead and put parentheses here and to make it a little bit more clear. And then that would be our result. You can distribute if you want. Let me go ahead and erase this. Okay, so if you want to, you can distribute that 2 on top and the x on the bottom, or you can leave it like this. So this is our new function, and it is the answer, f divided by g of x. Okay, so on this one, we have to consider a little bit more with the domain. So for f divided by g, the domain is pretty much all the numbers that we were allowed to plug into the original functions, but that we also have to be able to plug into the new function. So let me explain what I mean there. Let me show you the domain. So the domain, we have to exclude 4 because in the function g, 4 was not allowed. So we don't want 4. We have to exclude -3 because in the function f, -3 wasn't allowed. But then in the new function, look at what is a problem. If we put a 0 here, 0 times anything is 0, so we don't want that either. So we have to get rid of all 3 of those for our domain. So the domain is all x's except those 3 that caused a problem. So that one had a little bit more involved with the domain part of the question. Okay, so that's it for this one, operations on functions. So just remember that when you're adding, subtracting, or dividing or multiplying functions, you're just taking 2 functions and then you're making a new function out of them. And then you kind of just want to consider the domain at the end of your work to see if there's any numbers that you can't plug in to your answer. All right, thanks for watching.